This video is all about race conditions. The TLDR is that race conditions happen when correctness depends on interleaving. This means that the order in which each of the instructions from each of the different threads runs has an impact on whether the thread does its job correctly or not. You've probably seen the book explaining thread safety and interleaving using diagrams that look like this. You've probably also stared at those diagrams for a while and just thought to yourself, what? So we're going to work through this using an example. This is a simplified version of the unsafe code from the previous video. Remember that pseudo-random number generators like RAND are supposed to give the same sequences of outputs every time you use a given seed. But if any of these run before these, that invariant won't hold true. So here's a really ugly version of what was on the previous slide. This is what the authors want you to think of when you're thinking about using these diagrams. Each of the commands in each of these threads runs step by step. So at any time, the CPU can preempt one of them and put the other one on the CPU. So we can end up with a dangerous result if, for instance, we run the first two RANDs of the second thread before running any of the calls to RAND in the first thread. This is what will cause the output to be incorrect. We can solve this problem by making sure that neither thread goes into the dangerous section of that interleaving. We do that here by adding a call to pthread join. By adding this call to pthread join, we ensure that all three calls to RAND in the worker thread are always completed before the three calls in the main thread. This ensures that no matter what the interleaving is, it will always give the same expected output. So the three most important things to remember about race conditions are: 1. Races can cause incorrect results, not just crashes. 2. Progress diagrams help you visualize how certain interleavings lead to incorrect results. 3. We need to write our program so that interleavings which create incorrect results are impossible. There are several ways to do this, and mutex locks are just one of them. In the next video, we'll talk about deadlocks.